11. Observing the solar system. Astronomy throughout the ages. Before starting the lesson, I just wanted to ask if the paper is easy or not. I got 75. Please call me through my number 077 234 28 21 about the feedback. Okay, so now let's get started. Astronomy throughout the ages. Copernicus and Galileo are very famous for what they did. The geocentric model was inaccurate. For a long time, people believed in the geocentric model proposed by ancient astronomers. The geocentric model suggested that the Earth is in the middle and others orbit around it. Next, the heliocentric model. The heliocentric model suggests that the Sun is in the center instead. It is the most accurate model. Why can we see stars? A star is a super hot ball of gases. Hydrogen, common in stars, undergoes a process known as nuclear fusion. Stars emit their own light. The Sun is our closest star. The Sun is a medium-sized star but looks bigger and brighter than other stars. This is because planet Earth, is close to the Sun. It takes 8 minutes for light to hit Earth. Why can we see the planets and the moons? The planets and other objects in the solar system are not natural sources of light. They reflect the sun's light. Eclipses. We can see moon because it reflects the light coming from the sun. However, when the light from the sun is blocked by the moon or a planet, it is called an eclipse. A solar eclipse is causes the sun to appear darker during the day. A lunar eclipse causes the moon to appear more darker than usual. The phases of the moon. The moon moves along the tilted orbit around the Earth. It is a sphere and only half of its surface is lit up by the sun. The other side of the moon is never seen. Okay, so now let's go to our textbook. Page number 102. Astronomy throughout the ages. In primary school science, you have learned that the early astronomers Copernicus and Galileo made great contributions to what they know about our solar system. Yes. Next, the heliocentric model was inaccurate. For a long time, people believed in the geocentric model proposed by ancient astronomers. The geocentric model suggested that the Earth is in the center of the universe and other objects orbited around it. You can see figure 11.2, the geocentric model. Next, the heliocentric model. The geocentric model was then challenged by Copernicus' heliocentric model. The heliocentric model proposed that the Sun is in the center of the universe instead. Figure 11.3, the heliocentric model. Why the heliocentric model? With the invention of the telescope, Galileo was able to study and observe the planets. He observed that the planet Venus appears very much larger or smaller over a few months. If geocentric model was true, Venus would always be orbiting about the same distance from the Earth. Hence, its size would not change drastically. The geocentric model is unable to explain Galileo's observation over Venus. His observation of other planet size also suggested that the planets are orbiting around another object that is not the Earth. Galileo also observed there are four moons orbiting around the planet Jupiter. His observation again shows that the objects in the sky do not revolve around the Earth. However, the heliocentric model proposed by Copernicus was able to explain ancient astronomers' observations as well as Galileo's observation with the telescope. Thus, the heliocentric model was preferred by and used by scientists. Next, page number 104. Seeing the objects in our solar system. Why can we see stars? A star is a giant ball of superhot gases. Hydrogen, which is common in gas, it is a common gas found in stars, undergoes a reaction called nuclear fusion. This reaction releases a great amount of light and heat energy, thus enabling us to see stars to give off light. Hence, stars are sources of heat. They emit their own light. We can see stars because their light travels to our eyes. The sun is our closest star. Like all stars, our sun is a big ball of very hot gases. The sun is a medium-sized star but looks bigger and brighter than the other stars in the sky. This is because it is the closest star to the planet Earth. It takes 8 minutes for the light from the sun to reach the Earth. Next, page number 105. Why can we see planets and moons? Planets and other objects in the solar system, such as moons, are not natural sources of light. They do not emit their own light. The planets and the moon reflect the lights of the sun. We are able to see the planets when some of the light reflected travel into our eyes. Without the sun's reflected light, the planets and the moon will be not visible to us. You can see that in figure 11.6 and figure 11.5. Next, page number 106. Eclipses. We can see the sun because it emits its own light. We can see the moon because it reflects the light coming from the sun. However, when the light from the sun is blocked by the moon or planet, an eclipse occurs. From the Earth, we can see two kinds of eclipses. A solar eclipse causes the sun to appear darker during the day. A lunar eclipse causes the moon to appear darker than usual. Next, page number 108. The phases of the moon. Why does the moon appear to have different shapes at all the different times of the month? The moon moves along a tilted orbit around the Earth. It is a sphere and only half of its surface is lit up by the light from the sun. The other side of the moon is never seen. You can see that in figure 11.8. As the moon revolves around the Earth, we can see the lighted star side of the moon from different angles. This is why the moon appears to have different shapes at different times of the month. So, if you want to study that one, if you want, you can draw that figure 11.9. That will help you to understand it. We'll do science connect also. The Big Bang Theory, this universe is expanding. About 100 years ago, American astronomers used telescopes to look at the galaxies in the universe. Henry Leavitt measured how far away the galaxies are. Edwin Hubble measured how fast the galaxies are moving. The results show that the galaxies are moving very fast away from us. The conclusion was that the universe is continually getting bigger. What is the impact of this discovery in our understanding of the universe? So if you want to find out what is it, scan the QR code and watch it. because I didn't watch it. I will conclude everything in my WhatsApp channel. Okay, so yes, if please go and check my WhatsApp channel. The name is Learn Science with Damsana. So yeah, only that. Next lesson we had to do Unit 2C, putting things into groups. In this we had to do lesson 12, 13 and 14 also, I think. So yeah, only that. So stay safe. Goodbye.